Okay, so we're just going to take a look quickly at Nathan's discus throw to start with. Okay, so during the first steps of Nathan's discus throw, it's noticeable that he starts in a low loading position. This allows him to generate a spring to gain an upwards motion.
He does this by loading in a low position and then moving into a higher shape when releasing the discus. You can see this now as he unravels, he ends up in quite a high position. You can see two comparisons of this in Appendix 2.1 of an actual discus thrower. The only thing that differs is the range of motion that the discus thrower is obviously showing.
We've established that there is a major fault to Nathan's throw, and this is that he doesn't get a snap of the hips to generate the power from his lower body.
Instead, he just uses his arm at the stage in which he releases the discus.
The fault here being that the discus beats his hips, so therefore not helping him to generate power to gain a greater distance on the discus throw.
To give Nathan this feeling of the hip snapping through to generate power, he used a medicine ball so that he can toss it over his head with full extension through the hips to the final release of the ball. To see this, you can see it in Appendix 2.2. That's just a YouTube clip.
Okay, so even though Nathan's hips struggle to snap through, he does move both feet out of the way very efficiently to give him the space he needs to create a bow shape in order to bring the hips through first. Unfortunately, this does not happen. So we can see this in Appendix 2.3, where we have freeze-framed from this video Nathan with a very straight back rather than the bow-like finish in the model just to the right of Appendix 2.3.
To help Nathan with this problem, Lewis applied force to Nathan's throwing arm as he completed the full technique of the 1.5 spins in slow motion, enabling him to feel which components of the throw come first and last.